apart. Right, so in this topic we're going to be looking at magnets and electromagnets. So we're going to start with the very, very basics. Just a quick recap of something you would have done probably in primary school actually. If you take a magnet and you put it near another magnet, then they tend to attract, yeah? If you've got the North Pole pointing towards the South Pole, there will be a force of attraction between them, yeah? And they will attract each other, okay? If I then flip the magnet around, yeah, if I've got the South Pole pointing at the South Pole, then there's going to be a force of repulsion. They're going to repel each other. Likewise, two North Poles will repel each other as well. So like poles repel, and opposite poles will attract in magnets, okay? Now, if I've got... so let's have a talk about permanent magnets. Now, what do I mean by a permanent magnet? Okay, a permanent magnet is a magnet that has a permanent magnetic field established around it. Okay, it's always magnetic. Okay. Okay. Now, a magnetic field around a magnet is just a region where magnetic materials will experience a force. So magnetic materials or other magnets will experience a force when in another magnetic field. Okay. Now we can actually plot the direction of the magnetic field using a compass. Okay. Now a compass has kind of got like a tiny little bar magnet inside, where the North Pole of the bar magnet will always point away from north because it's repelled, and the South Pole will always point away from south and towards the North Pole. Okay, so if I wanted to plot the magnetic field, I would just put my plotting compass in the field, and the blue arrow will point away from the North Pole. Okay, so I've got a direction here. If I then moved it over here, then it will point out here somewhere. Okay, because it's pointing away from the North Pole. If I moved it down to the side here, it will point down towards the South Pole. Okay, I could then move it around here and it will come back around back to the South Pole here. Okay, now if I was to do this across the entire page, okay, it's pointing the wrong way at the minute. If I did this across the entire page and plotted exactly where the arrow was pointing all the time, then I would get myself a magnetic field. I could draw a magnetic field. Okay, so just by moving a plotting compass around the magnet and just putting a dot where the arrow is pointing, then I can actually produce a magnetic field. Yeah, I can actually draw the magnetic field. Now, if you did this, this is what you would do. Okay, you'd get a magnetic field like this. Now, if you are asked to draw a magnetic field in an exam, you will need to draw the lines from north to south. Okay, and then you'll also have to include the arrows pointing from north to south. The arrows are really important here. Okay, so the arrows will just be pointing in the direction that the plotting compass was pointing in earlier. Okay, now some areas of the magnet you've got loads of lines all together. Okay, there's like this area here, so loads of lines, loads of magnetic field lines together, really close. The spacing of the magnetic field lines will indicate the strength of the magnet. Okay, so at both poles, the magnetic field lines are really close together. There's not much spacing between them. That means that there's going to be very strong magnetism there. Okay, the edges of the magnet, they're slightly further apart, so the magnetic forces won't be as strong there. Now, what do we mean by an induced magnet? Okay, so I've got here a nail, or a bolt. Actually, this looks more like a bolt, I think. So I've got a bolt. Now, if I take my bolt and I put it in the magnetic field, then I will induce a magnetic field. I will induce magnetism in the bolt. Okay, if I take a magnetic material and put it in a magnetic field, that magnetic material will essentially become a magnet. Okay, this will become the North Pole. This will become the South Pole. Okay, so because this nail is now a magnet, it will experience a force. Yeah. So it will be attracted towards the South Pole. The north side of it will be attracted to the South Pole. Now, if I then took it out of the magnetic field and put it back over here again, it will very quickly lose its magnetism. Okay, so an induced magnet will become a magnet when placed inside a magnetic field. Okay, and because of that, there will be a force of attraction between that material and the magnet. Only magnetic materials can become induced magnets. So materials with iron in it can become a magnetic material. Cobalt and nickel. Okay, so the three magnetic elements: iron, nickel, and cobalt. Okay, so that's what an induced magnet is. Right, okay, I will see you in the next video.